Okay, hello, hi, this is Rani Ahmed with you, and this is lesson 24 on how to program using Haskell programming language. And this time we're going to dig more deeper in the data types. Now, we're going to start with something called enumeration, but before I start with the enumeration, I must talk about a reminder and how to create a data type. Let's imagine that I want to make a data type called color. You know, we want to give variables a custom type. Okay, and just if you want, you can revise the previous lesson about data types when we started using the keyword data. So we've got color, okay, and those black, red, green, blue, cyan, yellow, etc. okay, are all constructors. Okay, and the color can be any one of those listed between the pipes. Okay, so also, I must remind you that RGB will take, for example, if you want to make a color of a 24 or 32-bit color, okay, so you can just change the integer number here from, I mean, it has to be between 0 and 255, okay, so the three ints here must be between 0 and 255, okay. Now, this is just the data type. Okay, but what's an enumeration? Now, enumeration is that when you have a data type that it does not contain anything similar to the RGB with those three ints. Okay, like the constructor here must not contain any data type in front of it just to set it. Okay, so each one here must be just a name. Okay, like January, February, okay, etc. until December. Okay, now. The enumeration means also that the first name here will take number 0 and the last one will take the last count, like you start from 0, 1, 2 until you find here it should be 12, but because you started with 0, so it will be 11. Okay, so if you count 0, 1, 2 until you reach here, you feel yourself reaching 11. Okay, so this is enumeration. You're giving each number, okay, starting from 0, a name. Okay, so this is an enumeration, and again, you should not have any constructor parameters in any of those names. Okay, once it has, okay, this is not an enumeration. If you just find one, this is not an enumeration. Okay, now another quick way to define, for example, your configuration, okay, for something. Okay, let's imagine that I want to make something related to a username, and I'll make all the configurations and settings regarding a username. So you make, of course, a data type called configuration, and this is configuration as a constructor, which takes all those data types, strings and bools and other strings. Okay, and of course, just to tell your programmer or the user of those data types what are they, because just a string is just an ambiguous meaning. Okay, so you have to put comments like you see here: username and localhost and remote host and is guest and is super current directory and home directory. Okay, and if you want to make also getters, just to get those values, okay, of course you will have to put, just for example, you talk about the username, just put a data like a variable here, okay, and the rest put them as don't cares. Okay, anything, you know, the underscore means anything or don't care. Okay, so all you care about is just the UN, and which is the username, and just this way you will be returning it using the function get username, which will take a variable of type configuration. Okay, so from the whole configuration you're just taking the UN. Okay, and similarly for the rest, we just made and put a number of functions here, but this is daunting to change. For example, you're talking about the configuration of an employee, and every employee will have to give you a separate salary, you know. So you can make it like a database like a way by setting them directly. Okay, so like file and a table. So it's almost that, just setting it, poof, you know, don't have to think about making if statements and such, just to set and give a setting for every value. Okay, so I don't have to try something like if x equals 3, put me or give me 5. If x equals 10, give me 60, whichever, you know. So I don't have to go with this long definition of if statements. Okay, so what we can use is this way, which is clearer. Okay, so this is your configuration. Put that data type name. So instead of using the comments like what we have here. Okay, and next you can go with defining each data type as such. Okay, so this way you can later, for example, if I want to set it, you can just simply, if you're talking about using a change directory function, you know, you're on Windows or on Linux, you're using the command line and saying cd from this directory to this directory. So let's imagine that this function takes the configuration here. This is a CFG, and it takes also another string which is represented by the new directory variable here of the change directory function. And of course you should expect that it should give you another configuration for the directory that has changed. Okay, so we must take care of the existence of this new directory that I'm asking to change, because you're not changing from nowhere, you change from somewhere. Okay, so you say then this is how you shoot it. Okay, so you say current directory. See, from all of the data that's here, okay, and see how the current directories are highlighted. This is how you just set the new directory quickly. Otherwise, you will have to, for example, use a set function just to do it. Okay, so this is an easy way to do it. I like it so much in Haskell. This is one of the things that I like in Haskell. Okay, now because, for example, if you're going to use C++ or Java or maybe Objective-C, Objective-C has something. In Xcode you use something called, I think, prototypes. It will do it for you, okay, but it will generate the functions for you, get and set. But there's no need to make a function called get and set for everything. Okay, just simply write it as such. Okay, this is equal this. Now, otherwise, of course, you will be error, and it will give you directory does not exist. And this is error. I think it will print things on the shell, okay, here on the terminal. Okay, but those you won't be able to pass them to another command if you're using the shell. I mean, the directory does not exist statement, for example, it will not go to be grabbed or captured by another command. Okay, this is similar to using the stdr file and the cr and C++. Okay, like cr is cout, but just for errors, those will not be captured by other commands. Okay, as we said. Now, this is how we set it. Now, how we retrieve it? How do we get the current directory? So this is what we do. We have a function. For example, we created the one that will take configuration. So this is our getter. So you type just the configuration, you send the configuration, of course. This is the current directory of the configuration. Cool? Voila, as Swift. Okay, so fast. Now, and this is like a clearer way to set a configuration. See? Just username is body, localhost is nowhere. As simple as. Okay. Now, I have to go to the book, return to the book a little bit, because of some definitions which are so easy and they are like made better. Okay, they are my examples. Those are examples from the book, but I'm just finding it better to read from the book. So here he says that there is a data type called maybe. Okay, and this means, you know, maybe. So it can be this or this, okay, but maybe it means that it can be nothing or just a, which means can be the data type, as if you're saying it may be a string, okay, but it can be nothing, okay. So this is what you mean by maybe here, okay. So if you're looking up an anniversary, I mean a birthday anniversary, okay, so you're sending an anniversary list, okay, and you're looking for a birthday from those anniversaries. You're expecting, of course, to send the or return the data type as string, but you're saying by definition it can be or it may be an anniversary data type. Cool. So this means that by definition you can pass this output to another anniversary, or the return value can be also sent to another function as an anniversary. Now we have the either. You know, you say usually tomato or tomato. You know the song. So it's either this or this. So if you want to decide, okay, which one it can be, and this way you can send either types or return either types, okay. So it can the decision based on the left and the right keywords, okay. So A will be taking the left and right will be taken by B. So you can say here, as we see here in this function pair of, it will take an integer, it should return an either data type, but the either can be on the left side, the integer, and the right side, the string, okay. And here we're saying that people, okay, if it is less than 0, so give me the right side, so it should return this string, okay, can't pair, you know. And the left side and the right side too, if it's greater than 30, it should give you a string. So if you're talking about getting the value of the function even, just to return it to the pair of, okay, of people, so it will be the left side, and this is it, okay, by dividing by 2. Cool. Now otherwise, whatever else, okay, you just send from the right side a string contains can't pair of an odd number, you know. So this is also a way. Also group people, okay, it takes an integer to give you a string, okay. So case pair of people, okay, can be the right side or the left side, okay. And this is if the left of groups or the right of the problem, so you give me the groups and the functions, okay. So this is all about the data types in Haskell, okay, until now. If there is more, we'll see, okay. And thanks for watching. Please subscribe to my channel so you get new updates, and also click the likes, click the ads, watch the ads. They're important to you. Don't think they are not important. They might be. Okay, and thanks for watching.